In this lesson, we are going to learn about the principle of an astronomical telescope. Why do we use telescopes to observe the stars? Is it possible for us to see faraway objects in space with our eyes? Could she recognize the words on the signboard at this distance? Could she recognize the words now? Why can't our eyes see faraway objects? Can you give reasons? The best explanation is the visual angle of the light path from the object that falls into our retina is reduced if the distance is increased. Therefore, the image formed in our retina becomes too small to be interpreted by our brain, making the object to be unseen or invisible. To overcome this problem, scientists invented a device to enable people to see faraway objects. This device is known as the telescope. There are two types of telescopes, refractor and reflector. The telescope uses two different glass convex lenses, whereas reflector telescope uses two different concave mirrors instead of lenses. A refractor telescope consists of two glass convex lenses, while a reflector telescope consists of two concave mirrors. The primary mirror or objective lens is placed in the front end of the telescope, facing the object, whereas the secondary mirror or the eyepiece lens is placed at the back end of the telescope, near the observer's eye. The purpose of the primary mirror or objective lens is to initially enlarge the sight or visual angle of the faraway object, or, in other words, is to bring the faraway object closer to the observer. The secondary mirror or the eyepiece lens is used as the final amplification or post-magnification of the image formed by the objective lens, or in simple words, it enlarges the image that is brought closer by the objective lens. However, sometimes the light from infinity collected by the objective lens is scattered away from the lens focal point when entering the telescope. This kind of error is normally known as lens aberrations and subsequently blurs the final image. In order to eliminate this error, a third lens is placed in between the objective and eyepiece lenses. This third lens is called the field lens. The function of the field lens is to refocus the scattered light from the objective lens. As explained earlier, a telescope is built by combining two lenses or mirrors. The general properties of a telescope mainly depend on its lens or mirrors. These lenses and mirrors should always follow the criteria below. The focal length of the objective lens must always be greater than the focal length of the eyepiece lens. The radius of curve of the primary mirror must always be greater than the radius of curve of the secondary mirror. The invention of the telescope comes from the lens technologies which was developed by the Assyrians. Later, the Arabs and Persians improved the science behind it. The modern telescope for astronomical purposes was perfected by Galileo Galilei in 1609. A telescope is quite expensive to buy, but it can be built easily. monitoring the night skies for stars and planets, one day you might end up with one in your name. A telescope is a device that has the ability to make faraway objects appear much closer. The invention of telescopes makes it possible for us to study astronomy.